And it's me. Hi, everyone. Welcome back to the Astro Imaging channel. Glad to have you come back tonight. Let me just mute my thing so we don't have this going on again. Okay, we're muted. We have Kai Young and Brian Halber who are going to tell us more about the Seestar. And, I've got to say, I think that a lot of us maybe a year ago kind of looked down on the Seestar as kind of a toy that we weren't really interested in. But it's come a long way, and I'm really surprised. And the last time Kai was here, he showed us some very interesting things, and we're going to have even more of those tonight. So we are all changing our opinions, and please stay tuned and ask your questions when Kai does his presentation. Before we do that, I just we have a calendar coming up, and of course, we are always interested in new presenters. So those of you out there, I think we get more people looking at Seestar. So those of you who would like to come on, maybe you have another couple of tricks for using Seestar, come on and give a presentation, or something new, give that presentation. We are always looking for people. All you have to do is go to the astroimagingchannel.org, and there's a contact. Go down there, leave us a message, someone will get back to you. So tonight, Kai is going to lead the presentation. Next week, Dustin Brimberry, who is rescheduled. Yeah, he's going to give a presentation, Astrophotography for Beginners. We had to reschedule Dustin because he got sick a couple weeks ago. After that, we have Christian Sausage, Simplified Imaging Processing. Brave Falls is going to be here the following week, and he's built, with some other people, a whole new observatory, which I understand has almost Bortle 1 skies out there. That would be great. Jim Thompson's after that. After that, we have Neve, and after that, well, we had a few other opens that we'd love to have you suggest a presentation for. And before we get to Kai, Dustin, you want to give us kind of a short 30-second tour of what you're going to talk about next week?
Sure. Yeah. Good evening, everyone. Next week, I plan to just kind of talk about my adventures into astrophotography and astronomy. I've been doing it less than a year and learned a lot, made a lot of mistakes using Nina, and I was going to just kind of share some pitfalls and that I've run into, and just kind of some best practices that maybe I've found, and share some of my positive stories, as well as some battles that I've faced. So try to help other people that are new to the journey, because a lot of people been in astronomy a long time, but I run into people all the time that just never done it before, and they don't know how to get into it. So try to help people with that. So.
Always something to learn. Always something to learn, and always something to learn for those of us who've been doing it, 1 or 2 more years. Let's see, Kai, are you ready to take over?
Sure, let me present now.
All right, the presentation is yours.
Thank you. Let's see. Okay, can you see my slides? Let me get to slideshow.
Yeah, go to the slideshow.
Okay.
You're good.
All right. Thank you for inviting me back. A lot has happened in a year or so since we've been playing with Seestar. So I would love to share what we found with you. And I also happy to have Brian, one of our esteemed collaborators in our Seestar ELP project, to give a live demo at the end. Okay. So an outline, just get everybody up to speed. What's really Seestar? What's the basic features? This talk will be focused a lot on our new automation platform called Seestar ELP. Essentially, it's a cross-platform Nina to control Seestars, and there are a lot of cool features that we can pack into it, and hopefully we'll give you a flavor of what we have. As you also may know that Seestar is actually going to come up with a new firmware that will officially support EQ mode, And so we kind of covered that a little bit. We've been doing it for a year and 3 months, 4 months. So we kind of know what we do. So kind of give you a lay of the land. We also going to show you how we have a very cool polar alignment tool that's built into Seestar Alp, and I'll show you that. And then I'll kind of give you an idea, some of the new features that we actually use to kind of improve our imaging, and some of the pitfalls and some of the benefits you get out of that. We're going to do quite a bit of the demo in terms of what Seestar Alp can do. We can do session planning, we can do scheduling, we can do mosaic, we can control federation of Seestars, we can do trigger events. So any event would trigger actions. I'll show you some of the spectroscopy stuff we've done. If we have time, we'll do some photometry and some of the S30 possibilities that new model kind of exposed to us. Of course, at the end, Brian's going to give a full demo of the Alp. Seestar, really, most of you should know by now. As you heard before, a lot of people kind of looked down at it before when it came out. It's a cheap $500 toy, but really, it's actually quite a bit more than that. It's a quite nice APO triplet, 250 millimeter f5, has all kind of auto features, auto go-to. It's a autofocus with a photo wheel with actually 2 or 3 filters built in, dew heater, tripod, almost an ASI-like controller, and its battery, and all that 3 kilogram package. It's really cheap, and this is one reason why I got into it 15 months ago, because I figured it's actually a very nice package for educations and for STEM. So I kind of just dug in and actually just explore as much as I can and share what I learned. So to get started is the new buzzword right now with Seestar is that they're going to come up with EQ mode. So why to do that? Seestar by design is actually an azimuth scope. So what that means is that it's actually move both axes to kind of track the stars. And there are a whole bunch of issues with that, field rotation being one of the major ones. So if you try to track a target, because the sky moves or the star moves, it doesn't really track in normal equatorial mode. So the image itself, it's actually pretty nice in the middle, but the edges, a whole bunch of field rotation artifacts. So when you try to have a target with a pretty big field, outside it's all messed up. And it's actually worse than that. In the graph you see here, that the higher up the targets are, the worse field rotation it is. And of course, you actually do want to image things on top because you have less pollution and stuff. So it's kind of compound a lot of stuff. The other thing about with azimuth mode is that the rejection rate is pretty high because both motors are moving. So you got a lot of star trails. So typically you get around 50 to 70% rejections, even with 10-second exposures. And people are really pissed off about that. But we kind of fix all that when we do eco mode. And that's why one of the reasons why ZWO actually embracing it now. The other thing that they kind of compounded is that they actually introduced a lot of excessive dithering to kind of offset some of the walking noise. But they have a huge dithering intervals, and frequency is too high. So essentially every 5 frames, it just moved 20, 30 pixels. And if you have bad years and bad backlashes, you're going to have more star trails. So that kind of increase the rejection rates. So all that's kind of inherently bad with the Seestar. So as a background, like 14, 15, 16 months ago, I was actually posted a post right before Christmas, letting people know that I think I figured out how to do EQ mode. And that's essentially started my journey into this whole Seestar stuff. So fast forward to now. So now we actually are pretty well established that EQ mode is the way to go. I actually designed a few models. For example, when you have Seestar, the way it's designed is that the rotation axis in RA, it's actually not very balanced. But luckily, it is a metal bearing, so it's kind of okay. But for people who are near equator, you actually see the body is actually almost laying on the ground, which is really not optimal. So I kind of designed a few models to kind of offset that, so that when it rotates, it's actually well balanced. So I kind of encourage people to kind of explore different way of doing EQ modes and different setups. With this now, the rejection rate is now around 15%, or even better if you have better pull alignment. But in the old firmware, it still won't let you capture a lot of the targets if it's below celestial horizon, because it still thinks it's azimuth mode. But our app, our app that we're going to demo, it kind of worked around that, so the whole sky is open to you. And I think upcoming Seestar firmware will officially support EQ mode, so this limitation will also probably be removed as well. But even before we're doing the EQ mode, I actually play around with spectroscopy on Seestar. And by putting a decent grading in front, you can actually get a very nice spectrum. I actually have a few videos to show how people can do that. So what I've done recently is that I released a kit where anybody can just put a grading in front. Essentially, it's $1. And with that, you can actually start capturing spectra right in front when you see Seestar app, and actually analyze star spectra and absorption lines. You can actually see bomber lines. You can almost see that with just a simple $1 grading. And I kind of have demos and videos kind of show people how to actually do that. That's all in the resource I'll show at the end. But some of the things that I want to highlight in terms of the downside with Seestar is that the sensor that it uses is actually a relatively older sensor. It's pretty sensitive in that the read is actually pretty low, but you would see that there's a lot of IR signals actually going to be cut because Seestar actually has a IR cut filter. So all these nice photons will be gone. You won't analyze it. The other problem with these with the sensor is that there's a huge crosstalk. So you would see, for example, in the green channel, you would actually see signals that are contributed by the red photons that will go into your red channels, into your green channels. So if you're really looking at isolating nebula data, it's actually not the ideal sensor. And you also, if people who are into looking at the sensor's specs, you also notice that the sensor, the full well depth is actually pretty shallow. So it's nice if you're doing short exposures, or maybe it's doing a galaxy that can do some color balancing. But if you are looking at nebula data, you are getting a lot of crosstalk between your H-alpha and oxygen data. So what do we do about that? So one thing you noticed is that the sensors inside Seestar, there's a light pollution filter that's supplied to you. The light pollution filter is actually very wide. It's around 20 to 30 nanometer wide. I think it's even wider than the L enhance from Upsilon. So it's in a relatively light polluted sky, you do get some filtering, but of light pollution, but you're not getting much. You still see a lot of light pollution that contaminate your signal. So what we do is that I start advocating about adding external 2-inch filters. Like right now, I actually have a dual shield that can thread a 2-inch filter direct to it. So what I've been playing around with is that I actually put in dual band filters, which is 7 nanometer wide, or even mono filters at 5 nanometer wide. And Savoni actually came up with really reasonably priced 2-inch filters. So you can actually play around to actually optimize and really refine the data I can collect with Seestar, and put that right in the deuce shield so that it's pretty easy to use. And to see what you can get out of that is that these are a difference between the dual filter 7 nanometer filter compared to a built-in light pollution filter. From there, you can actually see quite a bit of the red, the HA type signals, and even you can see nebulas in this galaxy here, compared to just light pollution filter. So there are actually quite a bit that you can do by augmenting the optics and the filters. But the problem with this is that if you have very shallow, very narrow filters, is that you have lots less photons. So one good thing in here is that you can see the difference in terms of the background. You can actually extract a lot of light pollutions by using appropriate light pollution filter. But the problem with these is that because you have so less photons to play with, you have to have full control with the gains and exposures. But the problem with Seestar is that their philosophy is to give you a beginner type software, so that a lot of these parameters are not exposed to you. So you cannot change the gain, you cannot change the exposure much. But with the Seestar ELP that we're going to demo is that all that's now exposed to you. All the parameters that you used to with sensors, dithering, the gain, exposure are not available to you. So now give you a whole wide area to play around with different filters, and you can optimize your settings to fit your need and your sky quality. Okay, so what is this Seestar ELP? I'm going to just give you a very high level to show you some of the functionalities, and Brian's going to actually walk you through the workflow, how you actually can use it. Seestar ELP is an automation platform. So in here, the first screen is that you can actually have all kinds of commands to change any settings you want that are hidden behind in Seestar. They can actually change the gain, exposure, dithering, the focus, all the savings frames parameters are all exposed to you. We actually did reverse engineering of the communications. So we figure out what the commands are, and with actually help with Seestar actually. And so we actually reverse engineer the whole applications. So anything that you can do with the Seestar application itself, we can do and much more. So if you're used to having using typical AR astrophotography rigs, you have full control of the sensors, you have full control of the filter wheels. Now you have exactly the same full control. In Seestar ELP as well, we also have automated the whole polar alignment procedure. So before there's a whole bunch of sequence you want to go through to optically align your Seestars to get it just right so that it be polar aligned. But right now we actually have a one-button operations where once you set up in your rough polar alignment, it does everything for you in terms of doing the horizontal calibration and all the other stuff. On top of that, we actually have a polar alignment refinement, which essentially is a blind polar alignment tool. Will actually guide you to tell you how far away that you are from your polar alignment. If you're far away, your dot is going to be drifting around, and you can simply adjust your mount and your wedge so that you can get as close to polar alignment as possible. And this is all real-time feedback. So this is kind of followed some of like the sharp cap or the Nina type 3-star polar alignment procedures. But all that is automatically guiding you, so you can do that just with the software. In the Seestar ELP itself, we also have a full planning page where you can actually identify what targets to choose, and even doing the mosaic planning, how many panels, how to overlap, and all kind of astronomical data to kind of guide you what are good targets. So from there, once you pick a target, it automatically goes straight into our scheduler. We also have live views. We can actually do live monitoring of your image, and they do live stacking as well. And we actually are in a pipeline. We use third-party image enhancing and deblurring, so it can actually, the image itself is actually almost as good as coming straight from PixInsight. We have a full run scheduling capability. What this means is that you can plan out your whole night. You can schedule anything you want. You can wait for a time. You can wait for a period. You can do autofocus. You can change exposures. You can change the filters. You can do a mosaic. You can do a whole series of these images, and you plan it out in a run scheduler format. And another thing is that since I have more than one Seestars in my arsenal, I can control all of these as if it's one Seestar. What this means is that I can go ahead and configure these, treat these as one Seestar, and when I do a mosaic, I can tell individually which Seestar to do which panel, or they can all duplicate, or they can just duplicate by time. So all that is all conveniently exposed to you. So if I have up to 10 or 20, in theory, you can actually control that as just one big giant telescope. And lastly, we've been adding a few more automations in that we want live events to trigger actions. For example, I can actually monitor temperatures, or I can monitor the stars filled with half max. And based on some criteria, I can have that trigger actions such as doing refocus or actually redoing darks. So all that could be part of my scheduling. So it can actually, as the night go on, I can actually do a very advanced planning and triggers, just like Nina. And some of the upcoming things that we're looking at is that I'm going to integrating a staff or a SharpCap to actually capture some of the live stats like star count and full half max, or even plate solve data to kind of gauge how my night is going. And based on that, I'll feed it into my event triggers to kind of adjust my night schedules all programmatically. We also are putting more effort into doing live photometry. I'm going to start integrating ASTAP photometry capability directly into Seestar ALP. So that means that you can actually do a whole night planning to do photometry, and some of the photometry workflow will be fully integrated within Seestar ALP. Lastly, there's Seestar came up with a newer model called S30. Some cool thing about this is that actually have 2 cameras. So with 2 cameras, there's a lot of things we can actually play around with, in that we can use one camera to do star tracking, whereas the other camera we can do spectroscopy. So we can actually do live stacking spectroscopy with dual setup in a very, very portable device. So that's one thing that I'll be working on the next couple of months. Some of the resources that we have in terms of how to get more information about the application. The code is all open source in the GitHub. We have a active Discord channel and a Facebook kind of discuss the usage and the questions, and also have a bunch of YouTube tutorials on how to actually make use of all these functionalities. And let me pass it to Brian so he can actually demo how all this works together. All right? I'll pass to you, Brian.
Kai, can you stop sharing? Okay,
yep.
You're good.
Okay.
All right. Share screen. All right. So when Kai first released his Seestar ALP, it was all kind of command line based. You would interface with it with a standard JSON type client, and we a group of us got together and came up with a web-based front end for it, and this is what we have. This is the screen that'll come up when you first power it up. It'll show you information about your Seestar, all of the pertinent information. If I had more than one Seestar, they would all be listed here. So next step after that would be going into startup. So on the startup page, we've got some status things up here that'll tell you the progress as it's progressing through the actual startup sequence. And then here you can programmatically have it open the Seestar arm and rotate to a specified location. It'll perform an autofocus. It'll do dark frames, and then it'll start the polar line. And the one thing we do have here is we have the ability to override your latitude and longitude. So if you're away from home or working at a remote site, you can go and specify the latitude, longitude there, or the scope, aim, latitude, and longitude to open it up to a specific part of the sky for the area that you're currently in. And then once all of those processes finish, it'll return back your error for your alt and azimuth error margin. At which point in time you'll progress down to the PA refinement screen here. And when you click start, basically what it'll do is it'll tell your Seestar to start taking plate solves, and it'll just keep doing multiple plate solves as you do adjust the your declination and RA screws on your mount, and it'll gradually get you to where you want to be as close to the center as possible. Once you get used to it, it certainly becomes a lot easier. Then once you're all locked in for the night, then you're going to go to your schedule, and here's where you can go and say, well, if I wanted to set up ahead of time, I could wait until, say, let's see, 20 o'clock, and then add. We'll say here, well, let's do the startup, and then once the startup is done, then I can go ahead and say, I want to, if I want to say I want to image, and we'll go and we'll pick M42. And so we've integrated, you can actually have it go and query Simbad for the coordinates. Additionally, we have the ability to integrate with Stellarium, and you can, if you have an object selected in Stellarium, you can actually pull the coordinates from Stellarium. And if you have, say, a fit file from a previous session, you can actually click this and load that fit file, and it'll actually pull the coordinates out of that were recorded to the fits file. So then you just go and say, okay, well, I'm going to do, say, 2 hours. And as Kai had indicated, the default gain is 80. I'm in Bortle 8, Bortle 9 conditions, so I've upped my gain by default to 110. Seems to help a little bit. And once you do that, you just hit append. And so you've got your item here. And then, for a mosaic, it's very similar. So, M31 is one of those objects that doesn't fit in the field of view of the Seestar. So we've discovered that, a 3x2 works. 20%. If you're working in EQ mode, 20% is what you can use for your overlap. If you're using alt azimuth mode, 50% is probably will work. If you're going back and redoing a session for an object and you have specific panels from the previous session that maybe you didn't get enough time on, you can specify the list of panels here. And then you would specify how much time you want to spend on each panel. So, if I had 6 hours to view, to image M31, and I'm doing a 6-panel mosaic, I can do 1 hour per panel. And something you can do is you can tell it, go ahead and autofocus on every panel. So it'll perform an autofocus routine before starting imaging on each panel. And some stuff that we've recently added here, we have the ability to go and edit the actual schedule. The way it was before, when you set your schedule, if you screwed your schedule up, you had to basically just clear the schedule and start over. But so what I can do here is say, hey, I want to turn on my dew heater. And I know that I'm going to want to put the dew heater on and say insert. So now you have your dew heater turned on in between M42 and M31. And then you can go all the way through to the end of the night. Depending on how you want to do it, you can go and park the scope or tell it to shut down. And that'll basically run you through the whole night. And so once you have your schedule set, you have some options here. So you have the ability to export the schedule, which will actually export it to the host that's running Seestar Alp. You can download the schedule, which basically has it downloads it to the client that you're talking to the web interface with. And then, you could use the same schedule that you created the following night and say import if you did an export. So that'll load it from the local file system, and you can upload from the client. And then you can just clear your schedule if you want to clear your schedule, and you start all over. So let's see, planning. We can go to the planning page. The planning page it's a lot of we've integrated in several other websites where they have the ability to put like a widget on your web page. So this is from the Astro Mosaic site. So you can go and do all of that, and then once you figure out what you're going to do, and so say if I wanted to do M31 and I wanted to do a 3x2 and a 20% overlap. Did it not? It didn't take that, did it? There we go. So now we have our 3x2 that's here, and then I can go and I can click this button, and it'll actually send it over to the schedule screen, and you can go and specify, okay, well, I'm going to do a 20% over. Oh no, overlap's already there. Selected panels. Panel acquisition time 1 hour, and that adds it to your schedule. Down here, so there's information about twilight times. That's calculated based on the latitude and longitude that you provide in your configuration. We also have integration with Astrospheric and a couple others. You can actually configure which ones you want. Clear dark sky and clear outside are also integrated, so you can turn those on and off, and configure it however you want. This is where the real secret sauce is. Go into the settings page. This is kind of what Kai alluded to. These are all the settings. All these settings are available to you in the Seestar. They're just not necessarily all exposed in the native app. And so, you can go. This is all set to defaults. I have everything set to defaults currently. But the standard at 50 dither pixels, and every 5 frames it's going to dither. So you're literally losing 20% of your time dithering with the settings that they have by default. So 1 out of every 6, 1 frame every minute on a 10-second frame, you're losing. You can actually disable dithering if you want to. And we've kind of played around a little bit with this. The Seestar in and of itself, the tracking is not super accurate. And there is enough movement frame to frame that you can, on some objects, disable dithering completely, and basically just continuously shoot and not worry about losing any time. Stacking exposure length. So this is in milliseconds. I actually have it set to 20 seconds right now, or 20,000 milliseconds. And then the default, the continuous preview, the standard is a half a second, so 500 milliseconds. I have it set to 2,000 because, again, I'm Bortle 8 skies, so I need a little bit more. You tell it here. Seestar has the option to turn on saving the subframes. But if you have that turned on in the app, it does not save any frames that are rejected by the stacking algorithm on the Seestar. We have exposed that to Seestar, so you can enable saving failed subframes. And we found that the stacking algorithm that the Seestar uses for its live stack it's a little finicky. And there's a lot of times there's useful information even on the failed frames, unless you have some severe star trailing. Some of these, the auto 3-point calibration, the Seestar refers to that as a horizontal calibration, and that's they use that in the alt azimuth mode for that. Frame calibration, that's your darks, and then manual exposure. I believe you can go and you can set custom exposures, outside of the settings that I had shown earlier. And then of course you've got your auto power off. You've got light pollution filter. You can turn it on and off here. You can turn the dew heater on and off here. Say you already started your schedule and you forgot to turn on the dew heater. You can go and put that on here. And then the config file. This is the config that it uses to load by default. And so you can go and specify all of your information here. Here's all the settings that we were just showing in those pages. And if you set it here, then that information will automatically be loaded into your Seestar each time that you start up. And let's see. So we've got a go-to page. It's very simple. You just give it a target. It'll go to the site. It won't start imaging. Our live view, Kai showed you a screenshot. I obviously can't do anything tonight because it's cloudy and rainy here. So, but we do have star mode, lunar mode, and solar mode, and planetary mode are something that are not implemented quite correct yet. That is something that we are going to focus on in the near term, obviously with the lunar eclipse coming up. So we'll get that working here, in the next week or so, hopefully, before that happens. So that's kind of the basis of our tool here. We're always guest mode. In one of the more newer releases of firmware, Seestar added this guest mode, and I think they did it mostly to service outreach programs, so that you could have one master device controlling the Seestar and pointing it, and then you could have up to 7 other guests attached to that Seestar with their device, viewing what the Seestar is showing. And that really became problematic for us because you can only have one device giving commands to the Seestar. And so thankfully they saw the error in their ways and they made guest mode disabled, that you could disable guest mode, and it's actually disabled by default now. So we had a lot of problems with people who would constantly be saying, hey, my Seestar is not working in ALP, but it works fine in the app. And it's like, well, did you force close your app? And they said, well, no. So we're like, okay, we'll go into your app, relinquish control, and then go to this page in ALP and tell it to assume control. So it's little things that we've had to deal with over time. Things that they've changed that we didn't like change. And then on this commands page, this kind of gives you a rundown of all of the different commands, not all of them, but a fair number of the commands that we have determined are valid commands to the Seestar. So you can send all of these various commands: start autofocus, start your dark files, turn on so it does have a 3-position filter wheel, or it's more like a sliding plate where there's an IR cut filter, the light pollution filter, and then there's a dark filter that's just kind of a black plastic. And then there's all these get information commands. These talk directly to the Seestar and get the actual status from the device, on all of these things. So you can get all of the different coordinates. So you can get the RA and deck where it's currently pointed, get the horizon coordinates, equatorial coordinates. It's really, the API that they developed, it's actually a subset. It's based on the code that they wrote for ASI Air. So, because if you actually look at the code, you will see that it actually refers to itself as ASI Air, which is kind of funny. But we're always looking to add more functionality. I know Kai has a lot of things that he's going to be working on, you know, specific to spectroscopy and photometry and the S30. But I've been kind of the guy that's been doing getting a lot of the basic functionality up and going. So we're always open to suggestions for anything that you want. The best way to do that would be to go to our GitHub and register an issue. We'll take a look at that issue and kind of prioritize it with everything else that we have going on, or if there's somebody who says, oh, I've been wanting to do that, and they'll grab it and take work. If you want to help us, I mean, we're always looking for more help for anybody. This is all written in Python, a little bit of JavaScript and HTML. So, you know, I'm sure Kai would gladly take any assistance that we can get. You know, we can get with to keep the project moving.
For sure.
Brian, Kai,
Brian?
Yes.
We've collected a number of questions here.
Sure.
Eric, are you taking those? Or you
No, go ahead. I have a couple of questions. Go
Okay.
ahead.
Jerry says you keep on saying web-based, which implies you have the internet. Can you operate this whole thing without an internet?
Yes, you can. So the way I operate in the field, if I don't have internet service, I have a little. Actually, I have it right here. Oh no, I have a little portable internet router that's battery power that can work off of 12-volt DC power. I attach the Seestar to that little router, and then I can tell my tablet to talk to that router, and then it directly and attach the Raspberry Pi that Alp is running on. And so using that router as my network, I can talk from my tablet to the Raspberry Pi for the web interface, and then the Raspberry Pi talks across that same network on that little router to the Seestar to give it the commands to tell it what to do.
So you need a network that communicates with your own devices, but if you're a million miles away from your internet connection, it doesn't matter.
Right, correct. Yeah, and that's one of the other features that we actually have is we do have some an offline database that is local to the actual Seestar Alp install. It's not an exhaustive list of the objects, but I think it's something like 25,000 objects that you can actually query if you don't have internet service.
Okay. And you do that beforehand, or you say it's offline, meaning that it's stored someplace with you where you've made your remote network that isn't connected to the internet.
Correct. It's stored on the device that you're running the Seestar Alp the actual server piece on. It's part of the server code. Now,
I'm going to reveal a lot of ignorance here, and some of you who've known me for a while say, well, what's new? But we're talking here, the backyard professor wants to know about how he gets his, well, first off, he wants to know if it'll work on a Mac. Can he use a Mac with all this? Okay.
Yep.
And how does he get everything from the Seestar stuff onto his computer so that he can use it, so it's there? Or is it already on the computer? Or
no,
what?
so it is stored, the frames are stored on the Seestar. There's two ways to get the software off. You can plug it in via USB to your computer. It'll show up just like any other USB drive, and you can just copy the files directly from there. Or if you have your Seestar set up in station mode, where it connects to a wireless network, you can then connect to it over the wireless network using a network file share and copy the files over the network to your computer. It's much faster to use the USB option, but if you don't have that option, the network option works too.
I would add something to this as well. Actually playing around now that with mapping the Seestar into a network drive, I can actually now use SharpCap or ASTAP to do photo monitoring. So actually are using that as a live stream of data coming in to feed into these downstream processing app as well. So it's pretty cool.
And you guys, backyard professor asked, Are you guys the inventors of Seestar? And I think there's more to a story than that. So what role do you guys play in this whole thing?
Well, we're just a bunch
I-
of enthusiasts.
Yeah, I think I'm probably the first wave of people who bought the Seestar, and I fell in love with it, and I started digging into it. I was trying to engage ZWO because I saw some shortcoming with the platform itself, because they try to limit a lot of the capabilities because they figure people just want like an iPhone to click and just here's some image. But for us who actually want to dig deeper, we try to figure out how to actually get hold of a lot of these internal capabilities, and we hit a brick wall. So when I try to contact ZWO over and over again, and then it's just dead science. So I just say, oh, forget it, I'll just do it myself. So we start just tracking traffic and try to figure out reverse engineer the whole communication protocol. So that's
Okay,
how it
thank
happens.
And I think that's all that we've got right now from the comment section. For those of you watching, if you haven't done this yet, make sure you got comments open and you can write your questions in right there under the chat. Okay. There is from Jungchun, just yeah, that's what it is. Said that are there currently any issues in using the latest official firmware with Seestar Alp?
No, one of my Seestar is dedicated using the latest firmware, and I'm using that as a test bed. So if I find an issue, I'll fix it. But
Okay.
Guys,
And I think Eric had some questions he wanted to ask.
so you are all 100% familiar with your interface, but the rest of us, if we were interested and got started, we would probably get lost. So is there some get started videos or instructional manuals so we
yes.
could
So
all learn?
So one of my slides has the resources. So the first resource I would suggest is go to our GitHub wiki page, where you actually have quite a contributor who helped write a very good set of getting started procedures, as well as some specific answers on frequently asked questions. Also in my YouTube channel, there's actually quite a few videos on how to work on things. So yeah.
We're talking about your interface, right?
Yes, this is the Seestar Alp.
Yeah, and additionally, the Discord is open. We have a whole group of people who are, either veterans or newcomers, and we're a friendly bunch. We'll help anybody that comes. So that's another way to get directly in touch with us.
Okay.
Are you going to give us those URLs so we can find it?
It's in my presentation slides. It's probably the last slide right before the demo slide.
Okay. Mike, if you have a question, just go ahead and ask it live. You're in the room.
It's my understanding that the functions that pull from third-party websites, such as weather and that sort of thing, do require internet capability at that time. But as you said, most of the functionality does not require internet.
That's correct.
Correct.
That's correct. Yeah, in fact, there's a flag to turn off some of these, I think, these planning, because we do realize that some will require internet access, but they're not required.
Yeah.
And
Jerry,
I would prefer if you go in the field, actually, it'd be good to have a schedule kind of in mind and write your own schedule and save it. And then when you run, you simply just, when you're in the field, just run that schedule that you've saved.
Jerry was talking about EQ mode.
Mm-hmm.
So I think you showed a setup for EQ mode. Can you say a little bit more about it?
So Seestar, actually internally, the gear is actually labeled with RA and DEC in there. So for some reason, Seestar actually had it thinking it can run in EQ mode itself. But when it actually come into market, it's only marketed as an output node. So what that means is that it rotates, it sit flat on the ground, and then it rotates on both the base axis and the arm axis, just like a Dobson telescope. So in EQ mode is that it's a way to kind of fool this system, so that you can think of that as you can fool it in North Pole, because in North Pole they're both the same system. So you can fool it so that you can layer your Seestar so that it angled just like as if you're in North Pole, so that when it do track the star, it behaves just like in equatorial mode.
So that means you simply have a wedge, right?
You have a wedge, but there's actually some procedures, because Seestars, it actually, before it used some type of level to kind of orient itself, but it added what they call a horizontal calibration, which essentially is a three-star pole alignment to kind of orient itself based on the stars. So you don't have to worry about leveling. So that's one of the key aspects to kind of convert this unit into equatorial capable mount.
And what is the attachment? So the attachment is strong enough to hold it in some kind of a wedge formation?
Yeah, in fact, this is the hot item right now, is that since ZWO just announced that in any week, any day, any week now, it's actually going to release a firmware that will officially support EQ mode. So everybody's trying to figure out how to get into EQ mode. So typically, we've been recommending a few wedges, like a Skywatcher wedge, which is like $100 or something like that, which is simply formed at angle with the knobs. You can adjust the positioning. But I realized you don't even need a fancy wedge. In one of the slides I show, I actually use a simple hinge that I created that costs like $10 or $20. And then that's all you need. It's only form an angle so that your RA axis point in the direction of the polar axis. And that's really the key. And then
So what is what is the attachment point on the Seestar?
On the base of Seestar is a 3/8 inch thread threaded thing. So essentially you attach one of your angle to that base, and then the other to your tripod. So and those two surfaces form the angle that you want to kind of match the angle to your wedge.
So a simple camera mount, screw camera mount, can hold that 4 kilograms of scope?
Yeah, if you have a decent camera mount tripod, the only thing with tripod is that it usually is a ball mount. So when we create this pole alignment refinement, you can fine tune to get a very good pole alignment, but you really want to have kind of a nice control both the two axes independently. You don't want to be coupled like a ball mount. So it's doable. And in fact, with Seestar, you don't really need to have very good pole alignment. But I do recommend a 2-axis type wedge that you can get pretty cheap.
I actually saw an interview with the ZWO CEO who said they are actually going to release an official ZWO wedge that they intend to, to be used with the Seestar. So, that's coming. He didn't say when, but he did say it was in the wings.
Gentlemen, what is the image scale? Well, you got a 250 millimeter lens, and you've got a small sensor, but so your field of view, you can play with, but what's the ultimate resolution? What's that image scale?
The sensor itself, it's roughly I think 2K by 1K. I think the
1920 by 1080. It's 1080p if you're familiar with like a TV resolution.
Right.
And the field of view is like 1.4 degrees times 0.7.
Right, but what's a pixel? Ultimately your resolution is decided by your pixel and the seeing. But assuming perfect seeing, well, what could be your best resolution?
I think I wrote it down.
I think he's asking the arc seconds per pixel.
Arc seconds per pixel, yeah.
Yeah.
I think it was, well, it's roughly 1.4 arc minutes divided by 2K. So that's your
1.4 arc minutes per pixel.
I mean, 1.4
No.
arc degree divided by 2K. That's the.
Yeah,
I'm sorry, I didn't catch that. 1.4 what per second per pixel?
I think it's 1.4 arc degree, and that would cover 2,000 pixels. It's like 1980 pixels, I believe.
Okay.
I've got its sensor and scope information plugged into Stellarium, and it shows 4.3 arc seconds per pixel and 1.4 arc seconds per pixel on the other axis.
Oh, okay.
It should be 2 to 1.
1.3 times 1.4 arc seconds per pixel.
Yes.
You know, I'm curious, were you guys planning to show some images generated from Seestar?
We had a few in my previous presentation. I was going to do that today, but I could find some.
Yeah, I can.
We always like pretty pictures.
Yep. I've got some stuff that I've processed here recently too that I can share once Kai shares his stuff.
No, you can go ahead. Go ahead.
Oh, all right. Hang on. Let me find them first. Let's see. Actually, I can just do.
Guy, are there any concerns that with the new firmware update, it's going to cause issues with your application?
Always.
Yeah.
We've been always updating our firmware as soon as we find issues, but luckily they don't change much, and when they change, it's kind of predictable. It's sometimes they have kind of bonehead decisions I made, but we can figure it out pretty fast.
So I can share some of these pictures here. So I've got this is my album that I have out in Google Photos, but this is Bode's Galaxy and the Cigar Galaxy, and that's about 22 hours of imaging with the Seestar.
And that's from your Bortle 10 skies?
Yes. Yep. Yeah, straight from my backyard. And there's the jellyfish. That's a 2x1 mosaic, also from my backyard. I don't remember how much time was integrated on that one. This was it's a cluster of little nebula. They're all from the Sharpless catalog. I just decided to image it for something different. There's Spider and the Fly. That's a 2x1 mosaic as well. The Snowman Nebula. Fossil Footprint. Lobster Claw. Shrimp Nebula. Or no, Medusa. Shrimp's in here somewhere. So this is a moon shot that I took with the Seestar, and then I gave it the old mineral moon treatment where you crank the saturation on the color. This was shot. This is actually just a screenshot from the ALP, the ALP live view from the occultation of Pluto. So there's a tiny little speck, if you can see it, right where my pointer is, and that's Pluto just after it emerged from the moon.
Is that Pluto or Mars?
Or excuse me, Mars. Sorry. Yeah. So
I was going to say if Pluto was one, I would like to see that.
Yeah.
I can also share some of the pictures from our Discord members. We actually have a dedicated channels on Seestar.
Okay, good. Yeah, go ahead. Thanks.
Yeah, there's a couple of guys that are really big imagers and are really good at processing their data.
Yeah, let me try to find that. Okay, here we go. So this is our Discord channel. So these are some of the latest ones that people have submitted. This is Let me see the spec.
1333.
M78. It's
Yeah.
M78. Yeah, Casper the Friendly Ghost.
Yeah. Let me get 5 more here. Hold on a second. So, cigar mode.
Yeah, if you scroll up a little bit from that one, there's that M81 that the one guy shot.
Yeah.
That's
There's
fantastic.
Yeah, there's a lot on it.
Is there much of a presence on Astrobin of the Seestar? I don't think I've looked.
I haven't actually looked up myself. I should.
There are not that many because as you there's a stigma in terms of people using Seestars and so, but I think that the consensus has been changing. But some of the images you see from our Discord channel is just totally amazing. Let me try to find some.
Yeah, this one guy in particular.
There you go.
Yeah, this guy here that posted the M81. I know he posts his stuff out to Astrobin.
Yep.
And you see the Flux Nebula in that too. That's nice.
Yeah.
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 For $400 telescope.
Exactly. And in fact, I think he used just ultimate mode, not even pure mode. So it's just
he's alt azimuth pretty much solely because of I think he's on his balcony, the way he's set up on his balcony.
Find some more. Here's
another one.
Popular one, but that's a simple target. So, but you can see the details. I think that's like a 1 to 2 hour exposure.
Well, that's all IR cut. There's no light pollution filters on that. So that's how he got all the dark nebulosity there.
Yeah. Find more.
More of the of Bodes and Cigar for a little further up.
There's some more of that details in the Cigar. Find more. There's a triplet right here.
That's only 4 hours of data there.
Yep. Let's try to find
33 monkey.
There we go. That's
78.
Yeah.
This is 12 hours.
Yeah.
The optics is actually very nice. I think if you ever collect enough photons, it's because it's just a small sensor, so that the quality of the data itself is actually quite good. You don't have to worry about the aberrations at the edges because of that.
Well, that's great. Thanks. Appreciate that.
Sure.
It is the Astro Imaging channel. We always like to see pictures.
All right, I'll stop sharing.
Okay. Well, that's great. Are you guys, that's your presentation? Are we all set? Any more questions online? Alex?
Yeah, the number one question we get is, how do you guys get these pictures? And it's all about just getting enough data. Putting 15 minutes in on a target's not going to get you a great picture. It's a nice start, but hours and hours of imaging will get you exactly what you want if you're willing to put the time in and then the time processing.
Actually, if you're doing the mineral moon, or if you got a filter, you want to do the sun, I imagine you can do it in just a couple minutes.
Oh yeah, absolutely. Yeah, I mean, 30 seconds of video on the moon, it will get you about what I use to create that mineral moon.
Actually, when I use my array of 4 Seestars, it's actually comparable to my regular rig. So it collects a lot of data.
So can you collect video, or do you have to use with that?
Yeah, so in solar and lunar mode, it can do video. It actually does raw video, so you can then take it into like AutoStacker and Astro Surface to process, just like you would, off of a traditional rig.
How many frames per minute or per second do you get? Do you know?
I don't know offhand. I don't know that they're actually limiting it. Actually, the limit may actually be the actual flash memory in the Seestar itself, which is fairly slow. But the
Okay.
462 sensor was used as a planetary camera, by ZWO. So
Mhm. Well, I think we're all set. There's another question, Alex.
Yeah, I was going to ask a question. Guy,
Dustin?
I've got one of the Seestars. I've been playing with it, and I have have it in equatorial mode. But question is, I've been just doing it like manually, putting a laser scope and trying to line up a Polaris. I haven't used Seestar Alp to do the polar alignment. How close do you have to be to use that?
It's actually pretty forgiving, because if you're doing 10-second exposures, it's not too bad. But as imagers, we actually like to get as best we can. So that's why we create the tool to make it very simple, actually, to polar align. In fact, we can actually get it polar aligned within, I think the record is like 0.01 degrees in both directions.
Wow.
Besides, all you really have to worry about is field rotation, and I don't imagine you are worried about that.
Yeah.
Not for that field of view.
Exactly. Yeah. You don't. I think with this mainly is that you're not using the deck chasing the errors, so that any slop in your gears are minimized, and the only thing, the gear that we move is just RA in this case, in which case it's always moving the same directions, and the errors, corrections, you never have to worry about backlash. So that's my approach, is that get it in a decent enough so that my star trails is minimized, so that I get around 90 to 95% acceptance rate. And if I go ahead and reduce my dithering frequency, I can get my duty cycle is very high.
And you don't have to flip, do you?
No flip at all. No flip.
no flip.
No flip. Now, the other thing is that you notice in my EQ rig is that I actually attached the battery on the side of my Seestar. So when it rotates, it doesn't choke. In fact, the battery where it sits actually kind of balance out the whole axis, so that it's actually it's even better balanced than have the battery dangling on the tripod. So
yeah, I use mine on a shelf on my tripod, and I've got like a 6-foot cable that I wrap counterclockwise around the kind of the bottom of the Seestar, and as it goes clockwise nightly, it just unwinds until I've never had it get hung up unless it got hung up on some other piece on the tripod. So that works fairly well too.
I think one use case I've seen quite a few that I'm starting using more is that doing photometry and doing hundreds of targets overnight. So it just kind of walked all over the place. So there are different situations. So that that's why with this, essentially, I love Nina when I do my AP. So when I create this help, is that I kind of want that type of functionality, and flexibility. So I can do all that now with Seestar.
Okay, I think that about wraps it up. Thank you, guys. Very interesting presentation. Maybe I'll get one just to have it and play around with it, because it does sound interesting.
I tell you what, it's a snap to set up. So you're not dragging a big tripod with a and like an EQ5 or EQ6 mount and big heavy a big heavy reflector out there. So that's the thing that's killer. If I can make the decision 5 minutes before sundown that I want to set up, I can get out there and set up in 10 minutes and be ready to image.
On that note, I think we'll leave it. Everyone online, thanks for hanging in there with us, and guys, thanks for having us. So if we're all set, who's running the show? Patrick, you running the show? Okay, everyone, hopefully we'll see you next week for Dustin's presentation finally, now that he's back and healthy, and we'll say goodnight.
Bye-bye.
See you next week.